A2.
Hit. B8.
Miss. A3.
Ah, you sunk my battleship.
Yes.
So, if you have ever played Battleship or found the location of something on a map and many, many other uses, you have used the rectangular coordinate system. You have used what we know as the Cartesian plane. Okay, and so the Cartesian plane is the coordinate system. It's the x and y axis. Essentially, the Cartesian plane is made up of two number lines, a horizontal number line, which is the x-axis, and a vertical number line, which is the y-axis. Okay, and both of these number lines meet at 0. So that location where they meet is called the origin. That's 0, 0. And then along the x-axis, we count up from 0 using integers 1, 2, 3, 4. And to the left of that, there are negative numbers, negative 1, negative 2, negative 3, and so on. It doesn't necessarily have to be integers. From the center or from that origin, going up, again, positive numbers, and down, negative numbers. Okay? So our origin is just that middle. And of course, we write our ordered pairs x, y, alphabetical order. So the x coordinate is first, the y coordinate is second, and of course, the origin is just 0, 0. Okay, so our positive numbers as we move along the x-axis to the right, I can pick a location on the Cartesian plane, and this looks like 1, 2, 3, 4 on the x-axis and 1, 2, 3 on the y-axis, so that location would be written 4, 3. The Cartesian plane is split up into 4 quadrants. The upper right-hand quadrant is quadrant 1, and then proceeding counterclockwise. The second quadrant on the upper left. The lower left is the third quadrant, and the lower right would be the fourth quadrant. So quadrants 1, 2, 3, and 4. And in the first quadrant, all of our ordered pairs here, okay, since we're to the right of the origin and we're above the origin, those ordered pairs will all be positive, positive. So positive x's, positive y. In the second quadrant, here the x's are negative, but the y coordinate will always be positive. In the third quadrant, both x's and y's will be negative, or negative, negative in the third quadrant. And in the fourth quadrant, our x's are positive, but here our y's are negative because we're going to be below that x-axis. Okay? Very simple, but also very important concept. So, using the coordinate plane, the Cartesian plane, we can work with linear equations in 2 variables. We had the x-axis and the y-axis. This is still a linear equation because we're only to the first power, but this would be considered standard form of a line. So the graph of this, something that was in this format, would be the equation of a line. So below here I've got something 2x minus y equals 4. That is in standard form. And we know it's in standard form because A, B, and C are all integers. If A, B, and C are not integers, then we don't have standard form. Okay? And also, A must be a positive integer. So A must be positive. Okay? A has got to be positive. But the rest of them can be any integers that we want, and you can see here b is -1. So a is 2, b is -1, and c is 4. So that is an equation of a line in standard form. And we can graph this line on the Cartesian plane. Probably the easiest way to graph it is to find the two intercepts, the y-intercept and the x-intercept. Now the y-intercept, of course, is where the graph of the line, the graph hits the y-axis. Okay, just like an interception in football. Okay, you intercept the ball, you've caught the ball. Here we're catching the y-axis. The x-intercept, that's where our graph of our line hits the x-axis. Okay, so it's going to hit the x, and in this situation, we're going to hit the x and y-axis at some point on our line. Well, if we look at our coordinate plane here, okay, well, when we hit the y, let's look at the y-intercept first. When we hit the y-axis, okay, when we hit y, well, what's the value of x? Well, if we go down to our x-axis, when we hit the y-axis, well, that means x must be 0, right? Because this is like 0, 1, 0, 2, 0, 3, 0, 4, okay? So the y-intercept, x will always be 0. So to find the y-intercept, it's very simple. We can substitute 0 in for x to solve for y. So we put 0 in. So minus y equals 4. And now we can go ahead and solve for y. So negative y equals 4. So that must mean y equals -4. So our y-intercept is at the ordered pair, and it's always going to be an ordered pair, 0, -4, because x is going to be 0, y is going to be -4. So we can graph that on the Cartesian plane. So that is our y-intercept. Well, we can do the same thing to find the x-intercept, but when we hit the x-axis, we can hit the x-axis anywhere here. The question is, where are we going to hit it? Well, what's the value of y when we hit the x-axis? The value of y when we hit the x-axis will be 0. So now we set y equal to 0 and solve for x. So let's go ahead and do that. And we're using 2x minus y equals 4. I'm going to graph that line. So we get 2x minus 0 equals 4. 2x equals 4. And x equals 2. So then the ordered pair for the x-intercept is 2, 0. Y is always going to be 0. It's still an ordered pair. That's a location on the Cartesian plane. So 2, 0. So I can graph that particular point. And I know that 2 points make a line. I'll do my best to draw a line. And that is the graph of 2x minus y equals 4, found by simply finding the y-intercept and the x-intercept. Now, we can also graph a vertical line and a horizontal line on the Cartesian plane. Okay, y equals 3. We want to graph y equals 3. Well, equals is. We know that from our word problems. And I like to translate this as to y is always 3. Y is always 3. Well, if y is always 3, 1, 2, 3, y is always 3, well, y is 3 here, but it's 3 there, and 3 there, and 3 there, and 3 there. So all those locations, y is always 3. So apparently, y equals 3. This is the blue line. Should have done that in red. But y is always 3. Now let's go ahead and graph x plus 2 equals 0. Well, this is going to be a vertical line. process of elimination, I can subtract 2 from both sides, so I get x equals negative 2. X is always negative 2. X is always negative 2. Well, if x is always going to be negative 2, that means, there x is negative 2, but it's also negative 2 there, and there, and there. So anywhere along here, we get x is negative 2. And that's the graph of a vertical or horizontal line. On to the midpoint formula. The midpoint formula allows us to find the middle line between 2 points, or the middle between 2 points. So if I looked at the points negative 5, 8, let's go ahead and graph those, or plot those 2 points. And the other point, 2, 4. So 2 on the x, 4 on the y. So we'll plot those 2 points. Okay, so that's 2, 4, and that's negative 5, 8. Okay, I've got those 2 points plotted, but I want to find the middle of that. Okay, I want to see what is the middle point. Well, the middle point is going to fall right in between. It's going to be halfway over and halfway up. Okay, you can come halfway over and halfway up, and somewhere in there will be my midpoint. Well, sure enough, the middle point is the average. It's the average of the x's and the average of the y's. So all I have to do is simply add up my 2 x coordinates. Okay, my x coordinates are negative 5 and 2. So to find that, negative 5 plus 2 over 2. It's the average of the x's. The average of the y coordinates. The y coordinates are 8 and 4. I want to add those up and divide by 2. That's the average of 2 particular points. So the middle point, negative 3/2 and 6. So negative 3/2, which is negative 1.5, and 6, which I hope is right there, and that is our midpoint. Okay, so we can do that graphically. We wouldn't do that graphically. Because it's algebra class, we're going to use the midpoint formula and do our algebra. So using the midpoint formula, that is the midpoint.